Scientific notation, section 710. I was just telling you we need to finish up this chapter because we truncated the chapter for the test just because I didn't want you to have to go over the weekend. You know, truncated means cut short. Okay. Okay. Now, what I've done is I just put a couple of examples here just for us to talk about before we move on to the example down at the bottom for us to work on. Okay? But if you look at this first one, I mean, the reason that we have scientific notation is to be able to work with really big and really small numbers without having to have all of these zeros, I mean, these big, huge numbers. It just makes it hard to work with. Okay? So the way that we write it is the first number has to be between 1 and 10. It has to be a single-digit number. Okay? It can't be 10, but it has to be 1 or greater. Okay? So it's something times 10 to an exponent. Okay? And this goes with the things that we've been doing, dealing with exponents and the rules of exponents in this last chapter. But let's just review some of these things. Now, this first number is 118 billion. Okay? Now, the decimal point right now is here. But I need to make this number smaller. I need to make it somewhere between 1 and 10. Okay? So I'm going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to make it 1.18. Okay? But to keep this number equal to what it was when we started, I have to multiply it by a big number, right? Because it started at 118 billion and now I've made it 1.18. Okay? So I'm going to multiply it by 10 to the 11. The number of places, not 10. I just said 11 and my hand wrote 10. To the 11. The number of places that I moved it. Okay? Now, you can look at the, I mean, we don't really need to look at the next one. Let's look at this one here. It's a little bit different. Okay, this is 0.000152. Okay, what would that be? 152 millionths, I think. Okay? We need it to be between 1 and 10, so I need to make it bigger. I need to move the decimal point 1, 2, 3, 4 times. All right, so now it's at 1.52, but I made it a lot bigger. So I need to multiply it by a small number to keep it equal to what it was before. So it's 10 to the negative 4. Okay? You happy with that? Does that all make sense? You remember that from 7th grade. You remember that from 6th grade and 5th grade. Okay? I'm just trying to refresh you. Kyle, yes, sir?
Could you just said, like on number 1, you just said 118 times 10 to the 8.
You can't. It's not going to be in scientific notation unless this number, the first number here, is between 1 and 10. And that's a great question because we're going to look at some examples later where we're multiplying numbers in scientific notation, and the number we get out front is not between 1 and 10, and we have to change it. Okay, we'll get there in just a bit, but a good question because we want to keep it standardized. All right, so let's look down here. So Celia, help me with this first one. Is this a big number, A? Is A big or is it small, would you say? It's big, okay? We want to make it in scientific notation, so I need a number between 1 and 10. And I need to multiply it by 10 to the something, okay? Do you agree the decimal point's right here now? All right, count as I move them.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Can I stop there? No, because that's 58. 10. Is that all right?
Yes.
So it's 5.812. How many places did we move it?
10.
Do I need to multiply this by a big number? Should this be a positive exponent or a negative? It should be a positive exponent. Okay? Nice. Perfect. Okay? SK, help me with this next one. Okay? Big number or small number, would you say? Small number. Something times 10 to the something. Right? All right. I need to make this number between 1 and 10, so count as I move. 7. Okay, so that's 7.2 times 10 to the what? Negative 7. Perfect. You feel comfortable with that? Everybody feel good about that? Okay, let's look at the next example.